Hey there, what's going on? Welcome to Pluralsight. My name is Tim Warner, and the name of this module is Ports and Protocols. Here at Pluralsight, we have you covered for every single exam objective in the CompTIA A+ 220-901 blueprint. A learning path is a related set of courses. Each course tends to be a few hours long. It depends on the instructor, and the course is broken down at the atomic level to modules and clips. But I think I've just given you too much information. For now, I just want you to know that our A+ learning path consists of an introduction course, a hardware course, networking, which is what we're doing now, of course, mobile devices, and troubleshooting. And I would encourage you to cross-reference all of our topics here in those 4 content courses with CompTIA's published blueprint that you can download for fun and for free from the CompTIA.org website. I've divided the material in the networking course into 8 separate modules, the first of which covered network cables and connectors, essentially OSI Layer 1 stuff. TCP-IP Basics is what we just came out of. If you've studied that module, then you know some things about the OSI reference model, and we're going to build upon that knowledge in this module. Here we're concerned with ports and protocols, following up with Wi-Fi networking, small office, home office networking, internet connection types, network architecture devices, and networking tools. I have 2 main learning goals for you in this module. Our first goal is understanding the common ports and protocols. Fundamentally, what is a port, what is a protocol, and how do these terms relate to the TCP/IP protocol suite? CompTIA does have a good-sized handful of ports, protocols, and services that you need to know. You have to have them in your brain by the time you sit to take the 901 exam, so I certainly have you covered there as well. Let's get started. Meanwhile, in the real world, as a working A+ certified computer hardware professional, what kinds of questions can you see? Well, some of this is going to depend upon how much networking impacts your life. One question you're going to get, definitely from people with some technical background, would be, why would anybody use UDP rather than TCP? Another question is, can I host multiple websites on a single server? Admittedly, again, at least the first question is probably not going to be asked by Joe or Jane customer, but I've worked with plenty of non-technical people who know they need 1 or more websites to do their business, and they want to do that at least cost. As usual, we'll revisit these questions and answer them at the conclusion of this module. Our specific CompTIA A+ 220-901 objective is 2.4, which says that we need to explain common TCP and UDP ports, protocols, and their purpose. That's a lot of P's, isn't it? Port and protocol basics. I really should have stated this earlier, I guess I'll just state it now, that if you haven't watched the module on TCP/IP Basics, the one that comes just before this one in the learning path, go back and do that, because you really need to have some foundations on what these protocols are. TCP stands for Transmission Control Protocol. It operates at the 4th or transport layer of the Open Systems Interconnection Networking Reference Model, and TCP is called a connection-oriented protocol. The reason for that is that when data comes down through your application and is finally segmented into segments at the transport layer, TCP is concerned with reliable delivery of each and every one of those segments. So, TCP, your transport layer protocol, and whatever layer 4 protocol you're using for sessions are going to function closely together to make sure that those segments are sent out in the proper order and received in the proper order by the destination computer. A plus of TCP is just that. You're reliably delivering data from host to host. This is why most of the most heavily used networking protocols and services that we'll look at later in this module use TCP, because it does reliable data delivery. Now, to every rose there's a thorn, right? A possible negative of TCP is that it's slower than the alternative because of that extra overhead. The sending computer and the receiving computer are constantly checking as they, on the receiving side, build up the bit stream from layer 1. Those bits come into the destination computer's network card and are brought up into layer 2 Ethernet frames, and then they're built up further and we expose the layer 3 IP addresses, and assuming that the packet has passed muster at that point, it's assembled yet another step to reveal the TCP data, and at that point checksumming is performed, and if a segment has been damaged, then the target computer will send a notification back to the sending computer saying, I'm missing segment 636, or segment 401 is corrupted, please resend. It's amazing when you think of all this communication that happens between two computers and you don't even know it as an end user. Now, UDP is the other alternative as far as a layer 4 transport layer protocol is concerned. It stands for User Datagram Protocol, and UDP is a connectionless protocol. I call it a best effort or message in a bottle protocol, and that's its real advantage. It's a lean and mean protocol because it doesn't have much overhead at all. A server, let's say a client computer, does a lookup with DNS saying, well, when I say saying, I'm saying that the request from the client to the server is asking for, say, what is the IP address of www.google.com? The DNS server receives those requests in DNS messages that are operating on UDP port 53. Well, there's no checksumming. If the segment reaches the destination, cool. If not, then perhaps the client will send another message. So there is an advantage to that as far as speed. The con, though, is data dropouts, because you're not going to have the receiving computer sending notifications back to the sending computer to resend, okay? Now, this affects application developers because when they build network-aware applications, they have to decide which protocol or protocols they'll use and whether they'll be using TCP or UDP. So this is more of a software architecture question, but certainly from our standpoint as A+ or Network Plus certified technicians, we need to understand this stuff as well from a more practical standpoint. Sockets is a term that's bandied around. If you've done any work with Unix, Linux, the term is used much more prevalently there. Nonetheless, let's consider the case of a client computer that has the IP address 192.168.16.205 attempting some kind of communication with a resource server that's on a completely different network, as you can see, 203.0.1131. Now, how does the server know, especially if this is an internet-facing public server, let's assume that it is, what traffic is destined for which application and which host sent which traffic? There are so many plates spinning, like I said, when you think about it, it's crazy. Well, the socket refers to a combination of an IP address and a TCP or UDP port number. Right now, I really want you to drill into the idea that these port numbers are associated with particular protocols and services, and they're what allow client-server communications to function. For instance, let's imagine that this server was hosting a website at the DNS name www.company.com. That web server software is going to be listening for incoming connections on its IP address, 113.1, on TCP port 80. So if traffic comes in on port 21 or port 23, the web server component's going to ignore those messages. It isn't until the client computer, maybe the user dials up their web browser and types www.company.com and presses enter, that the request goes across the internet. And that request, in fact, will specify at first the www.company.com, but that gets translated by DNS into the 113.1 IP address. And because those are HTTP messages, HTTP is the protocol of the World Wide Web, and because the HTTP protocol listens by default, once again, on TCP 80, you've got yourself a service. Now, to answer the question, how can a single web server host multiple websites on the same machine? Can it be done? The answer is yes, it can, and you need to be a little bit fancy because those sockets need to be unique on a machine. So one thing you could do, if you had need to do two websites that both listened on the default HTTP port, you could bind an additional IP address to the server. That way you still maintain the uniqueness of that second socket. Something else you could do, let's say the server had just the one 113.1 IP address, you could put your other web server on a different port number. What some administrators do will put a second website listening on TCP 8080. That's because it's easier to remember. The thing about using non-standard ports with applications and protocols is that the user will oftentimes have to specify specify that alternate port. So in this case, the user on the client box would need to type in www.company.com:8080 to connect to the appropriate service. You see what I mean? Speaking of applications and services, the file transfer protocol is, well, it's used for file transfer. You probably knew that already. That application listens on TCP, that's the protocol, 20 and 21, two port numbers. So the same song and dance. The server will listen, the FTP server that is, will listen for incoming connections on its IP address only on TCP 21 and 20. Isn't that great? So I hope that this slide in particular has helped drill in or illustrate the importance of protocols, ports, and port IDs. Well-known ports. Let's learn a little bit more detail on ports. First of all, these socket ports are in fact maintained by the Internet Assigned Numbers Authority, or IANA. Remember that I mentioned this in the previous module. IANA is actually founded by the United States government. I laugh when I say that because IANA takes global charge of not only IP address allocation, but also the domain name system root zones. And in our case here, IANA also specifies and doles out port numbers. Now, the port number address space is 16 bits wide. And if you do the math there, it would be 2 to the 16th power because we're talking about binary digits or bits. That turns into ID 0 through 65535 in decimal. Now the well-known range goes from port ID 0 to 1024, and that's where all of the ports that you need to memorize for your A+ exam fit in. They're well known because they're standardized around the entire world. The two examples I gave you in the previous slide, HTTP being TCP port 80 and FTP being TCP 21, those are examples of well-known ports, and you want to use those so you can maintain standardization and consistency around the world. The range from 1024 to 49151 is called the registered port range, and this is where, for instance, if we wanted to develop a line of business network application, we can configure it to listen on a particular port. Now you may run into conflicts with another line of business piece of software, but there's no reservation made for those IDs. Finally, the dynamic or ephemeral range goes from 49152 to 65535, and many network services will connect initially on a well-known port number and then switch to a dynamic port way up high in the range and use that for subsequent communications. That can be useful if, for instance, a web application needs to have communication happening on more than one socket. Instead of hammering a single well-known port, you can open up a range of ephemeral ports that are used for the duration of that particular session and then are let go afterward. Port and protocol lineup. This is the moment we've all been waiting for. I'm going to run through a few slides and give you 20 or so ports and protocols that, I hate to say it because as a teacher and as a student, I never like to recommend memorization, but this is information that you'll wind up using for the duration of your career, so I'm very comfortable asking you to memorize this information now. It'll pay off in the short term when you pass your A+ exam, and it'll pay off in the longer term when you're in industry. So here we go. I've ordered these ports and protocols from low port to high, so we're starting with the one we've already seen, file transfer protocol. Then we move to port 22. Now most of these services use TCP for obvious reasons. When there's exceptions, I will mention those as we go along. TCP 22 is the secure shell protocol. This is used for encrypted, safe communication. You can use SSH to do a remote command prompt, and you can also use it for file transfer using the same command set that FTP uses. SSH is in OS X and Linux Unix by default, but if you want to do SSH in Windows, you'll need to install the server and client bits from a third party. Port 23 is the well-known port for Telnet. This is one of the oldest protocols. It also gives you a remote command prompt. You can remotely administer another machine or a router or a switch, but it's unsecure inasmuch as any username or password data is all transmitted in clear text. Port 25 is the simple mail transfer protocol. SMTP is very, very common for email delivery. It can be abused, unfortunately. It's a vector for scam marketers. Port 53 uses UDP as well as TCP. This is the domain name system, and we use this for host name to IP address resolution. UDP 67 and 68, message in a bottle, dynamic host configuration protocol. This, as we know, is used for IP address assignment. Ports 80 and 443 are the hypertext transfer protocol and the secure hypertext transfer protocol, respectively. They're used for web content. And because these ports are so standardized, you can use applications like the FileZilla client does both FTP and SSH. And any web browser worth its salt understands HTTP and HTTPS, so you generally never have to specify the port number when you're addressing a remote host. It's assumed because we're in the well-known range. Port 110 is POP3. This is the post office protocol, and it's used for email download. You would download email from your internet service provider, for instance, using POP3. POP3, unless you specifically configure it otherwise, is going to remove the mail from the server, though, so for that reason, some users, including myself, prefer the IMAP protocol that we'll discuss in just a minute. The server message block protocol uses TCP 137 through 139 and 445. Those are sensitive protocols you want to be careful of on home systems in order to warrant against abuse, because SMB is the Windows file sharing protocol, and it's been that way for a long time. TCP 143 is the well-known port for the Internet Message Access Protocol, IMAP, and this is used for both sending and receiving email. It's more flexible than the post office protocol. 161 and 162 are the Simple Network Management Protocol, or SNMP. Yes, it's commonly confused with SMNP. Those are tongue twisters. We use SNMP for network device management. The protocol is a little bit long in the tooth, but it's useful. You can perform hardware and software inventories and so forth without much additional overhead. TCP 389 and 636 refer to unsecure versus secure LDAP, Lightweight Directory Access Protocol. This is used in Active Directory. Active Directory in Microsoft Windows is an LDAP directory store. We have Open LDAP in the Linux Unix world. We have Open Directory in the OS X world. It's a directory database where you can manage users, groups, computers, and so forth centrally. Ports 427 and 548 are the Apple Filing Protocol. Used for file sharing, this was used many, many years ago in Apple-based peer-to-peer networks, but fortunately Apple got on the TCP-IP train within a few years, so you'll find nowadays that if you're doing file sharing on OS X, I can tell you, you will be using SMB when you're communicating with Windows boxes, and you'll probably be using Network File System, or NFS, when you're doing file sharing with other OS X or Linux machines. Interestingly, NFS is not one of the protocols that we need to know for the A+. Finally, and this is the final one, although nuts, I just realized there's one other I need to talk to you about. In fact, let me cover that now. Look in the second row, SMB. SMB is actually the older name for another protocol that does the same exact thing, Windows-based file sharing. It's called the Common Internet File System, or CIFS, CIFS. CIFS and SMB use the same TCP ports, so it's not like you're having to learn two totally separate protocols. Okay, now that I've finished that, let's go to the bottom of the table, and we'll wrap up with TCP 3389. This is, even though it's not in the well-known range, it's been so standardized, it's used de facto around the world for Windows remote desktop sharing. In fact, the protocol is RDP, that stands for Remote Desktop Protocol. In this demonstration, I want to work with ports and protocols. This is a Windows Server 2012 R2 machine, and I'll open up an administrative PowerShell prompt, CLS, to clear the screen. There's a command line tool. This is not PowerShell. This is an old command line tool that's been in Windows forever, it seems, called netstat. Wow, look at that. It's just going crazy. I'm going to have to do Control-C to stop the output. That was just unbelievable. In fact, I ran out of buffer space. I can't show you anything but these entries here. But netstat is a quick sanity check to see what kind of TCP/IP connections are happening on your machine at the moment. Another tool that I feel is infinitely superior to netstat on Windows systems is called TCP-View. This is a sysinternals tool. Mark Rusinovich is the CTO of Microsoft Azure, and before he joined Microsoft, he and a guy named Bryce Cogswell made these really awesome system utilities, and Microsoft wound up buying all of the source code, and they also hired Mark. And they still maintain the software, so it's still around. But as you can see here, my Chrome browser is doing a whole bunch of crazy crazy stuff. Look at all these connections, and I want to draw your attention to the protocol. Now notice that we have entries for TCP v4 as well as TCP v6. And it's given you the local host name, the local port, the remote IP address, the remote port, what's being used, and then the state of the connection. Now, in my experience, I'll use a tool like TCPview a lot when I suspect that a computer may have been compromised by some kind of malware, because you want to look for any connections that look kind of wonky or unfamiliar. All of these connections look pretty good to me. If you right-click a connection, depending upon what kind of process it is, you can get a link to its executable, you can end the process. So again, TCPview is a free utility. Now, what I want to do is use Wireshark, which is a free and open source protocol analyzer. I'm going to ask you to look at the Pluralsight library because my friend Ross Bagurtis does some really great Wireshark training for us. So this isn't a Wireshark course, but I'm just going to use it in line here. I'll make sure that my proper interface is selected and I'll click Start. What Wireshark does, it acts sort of like a vacuum cleaner. It starts sucking up every inbound and outbound Ethernet frame that this machine is experiencing. So at this point, let's see, I'll come down to my notification area. I don't think I have it running, so let me start it. I have a very basic FTP server running on this machine. FileZilla server is again a free and open source FTP server. I think it's not on this machine. Let me switch over. All right, so here we are on another member server. Sorry about that confusion. Let's see, yep, it looks like our FileZilla server is running, so I guess I'm going to need to start a Wireshark capture over here. Again, let's verify the interface and click Start. What I'm going to do, just to tell you in advance, is that we're going to go to yet a third machine in my network, a Windows 8.1 box, on which I've installed the FileZilla client software. So we're going to make an FTP connection and then look at the results of that capture in Wireshark, and you'll see how easy it is to understand the OSI model and ports and protocols using that tool. So here we are on our Windows 8.1 box, FileZilla client. I'll type the host name. I happen to know the credentials because I created them. And we won't specify a port because by default, and as the tooltip tells us here, unencrypted FTP uses 21. So let's quick connect. The successful connection happened immediately, didn't it? And all I have in the share are some Pluralsight desktop wallpapers. Let me shift my local view to the desktop, and I'll just download a couple of the files. Again, it happens instantaneously because of my network speed. And then I will disconnect, and there you go. Let's head back on over to the FTP server now. We'll bring Wireshark back up, and we'll click Stop running the live capture. Now, one controversial thing with Wireshark or any other protocol analyzer is how to most efficiently cut down on what you're seeing. Because if you look here, I guess I didn't capture that many frames. It looks like I've got 149. But if you do a longer running capture, you can wind up with thousands and thousands of frames. So one thing you can do is scope what kinds of traffic you want to pick up on the capture side. The other argument is to capture as much as possible and just pick it up on the display side. I was going to use a filter, but come to think of it, there's so few messages here, I think we can just go ahead and scroll through and see what's going on. In the upper field, we have our frame list. Remember that frame is the protocol data unit term that's used to define data at OSI layer 2, the Ethernet frame. Then when we look at layer 3 data, that data is considered to be a packet. And when we're at layer 4 looking at TCP and UDP ports, that's considered a segment. Now look at this. This bit right here is really important. This is the initial connection incoming to the server. Because I'm doing unencrypted FTP, even though FileZilla client originally requests to use encryption, TLS stands for Transport Layer Security. It's the successor to Secure Sockets Layer, or SSL. And yes, you can use TLS SSL with FTP, but the server's not allowing that. So instead, look at this. Request user student, request pass, and there's the password in plain text. Not good. That shows you very clearly the unsafe nature of unencrypted FTP. You definitely want to use either an SSL certificate or you can use the file transfer capabilities of the Secure Shell protocol. But you can follow through here. First, we see the top-level directory listing. We're switching to passive mode. And then here we have our downloads, our transfers taking place. Yep, here's one right here. An FTP download request for that author desktop Aqua file. So that's one thing, to look at the frames in the frame list. As you can see, it gives you the frame number, the timestamp, the source and destination IP addresses, the protocol. FTP is an OSI layer 7 application layer protocol. TCP, of course, refers much farther down the stack. In fact, let's look at that data. Let's come up and look at a representative FTP message, this one right here. Once you have a frame selected, come down below and you can actually expand all of the different header fields in that frame. There's an outer layer header that gives overall frame level data. And then we go to layer 2, OSI layer 2, Ethernet. And of course, at the layer 2, we're expecting to see traffic that involves MAC addresses, source and destination. SRC is source, DST is destination. Now, of course, you're probably wondering, how do the hosts determine the other's MAC address? And there's actually a protocol for that. You know that old saying with smartphones, there's an app for that? Well, in the TCP-IP protocol family, there's always a protocol for that. And as it happens, the Address Resolution Protocol, or ARP, is used to resolve hardware addresses. Probably in this capture there weren't any ARPs going on because my client computer and this MEM server have been communicating all day, so I'm sure that they've cached each other's MAC addresses. Then moving up the stack to layer 3, we have an Internet Protocol version 4 header, and there's lots and lots of properties as you can see here. But the main ones I want you to look at here are the source and destination IP addresses. And again, you need to ask yourself, how did that client computer know the destination IP address of the server? Well, it didn't, because you'll recall in FileZilla Client, I specified the DNS name of the server, so there's likely some DNS lookup going on as well. Closing up the Internet Protocol, we come up to OSI Layer 4, and we have the Transmission Control Protocol, again, very clearly stating source and destination ports. This is a good example of the differentiation between a well-known port and an ephemeral port. It looks like that this session, while it's initially connecting on port 21, it's actually going to work on an ephemeral port in the 51,000 range. Just because it's kind of fun, and I want to show you some of the other kinds of traffic that's possible, let's close this current capture. I won't save it. Again, we'll verify the interface and start. This particular machine has a connection to the internet, so I'll go back to the start screen and start Internet Explorer. I'm not going to care about the MSN homepage. Instead, I'm going to go to my own website. And this is not free advertising, I promise. This is for very real reasons. TimWarnerTech.com. Good. And so, as you probably know, when you visit a website, you're using HTTP or HTTPS, and you're actually downloading all the assets on that level, on that page. So the HTML page has associated graphic images and cascading style sheet information, etc. Let's just pop open our capture, stop it, and let's see what's shaken. All right, so in inspecting the results here, we have just about 300 or so frames for just a very brief capture indeed. Let's type our filter, DNS, and press enter. I just want to quickly show you that when you're hitting a website, in my case TimWarnerTech.com, I don't know it, but my web browser may be doing a whole bunch of additional queries and lookups, as you can see. Remember, when you open the web browser, you initially, unless you've changed the address, you wind up seeing some kind of Microsoft link. But here we go, a DNS standard query for TimWarnerTech.com. Let's just finish this demo by looking at this. So after we get past that, you'll see finally we see queries and query responses. It looks like my machine was looking for both an IPv4A record with an IPv4 IP address for TimWarnerTech.com as well as a quad A IPv6 address. And it looks like I was given a standard response of 506377.1. So I connected using IPv4. There's a lot more about this that I can get into with you, but we'll have to hold that in abeyance for now for time purposes. Back to the real world, let's answer those two questions that we had. The first of which was, why would anyone use UDP when TCP is so cool? I mean, by cool, I mean it has the error correction, it has the notification, it's reliable connection-oriented delivery. Well, we already know the answer. If you have need for a network service or application that has less of a priority, frankly, and or you want low overhead and faster performance. As far as the second question, can you host multiple websites on a single server? The short answer is yes. As long as your IP address and port number combination are unique, you can have far more than one website on a single web server. For homework, I'd like you to download Wireshark. It is free. It runs on Linux, OS X, or Windows, so you should always be able to get it. You can even install Wireshark on mobile phones, for heaven's sake. And I want you to develop some comfortability with network traffic. The wireshark.org website has excellent tutorials. Check the course notes for this module because I give you the download links and the links to the documentation. I also want to challenge you to research how you can be safer when you're browsing online. Not just you, but those whom you care about. I'm thinking of stuff like using SSL or HTTPS instead of HTTP. For instance, I use on my Google Chrome browser, that's my go-to browser, an extension called HTTPS Everywhere. Similarly, I will always prefer encrypted FTP to non-encrypted, and so on. For further learning, we have Chris Ree's course on the CompTIA Security Plus. His network security course has a module entitled Common Protocols and Services that bookends what we're doing here very well. Of course, Chris is emphasizing the security aspects there because that's the focus of that certification. Ross, as I've already mentioned, has done a lot of Wireshark training for us at Pluralsight. Look up his introduction to Wireshark. The course clocks in around 2 hours, 43 minutes, and in my humble opinion is well worth your time and effort. In summary, what have we learned? Well, we know that sometimes memorization is a necessity. In this case, the time that you invest in memorizing the ports and protocols that we covered is going to bear fruit for you in the short term because it'll help you pass your A+ certification. In time, I'm convinced that you'll develop a feel, an intuitive grasp of protocols, ports, and applications. And as I've said before, having the data in your brain resident as memorized facts just makes that easier. So I feel comfortable suggesting memorization here. In our next module, we'll look at networking from a wireless point of view. Thanks a lot for your participation. I'll see you then.